Hello everyone, today we're going to solve an easy problem 3296, minimum number of operation to make elements in an array distinct. So with this problem we are given an integer array nums and we need to return the number of operations to make each element distinct. But we have constraint. We should remove only 3 elements from the beginning of the array. And if the array has fewer than 3 elements, we remove all elements. So, also information noted that an empty array is considered to have distinct elements. So we return minimum number of operations needed to make element array distinct, and minimum operation will be in our case return 0. Yeah, no elements. So we have few examples where we have numbers, and for example we encounter some duplicates and we remove first 3 elements again and then first 3 elements again and make distinct array. Same goes here, we remove first 3 elements, we have 4, so we need to remove all of them to make the array distinct, and we have 2 operations. Kind of from this logic, we can see that it's better to count elements from the end, like here, because if we start traversing 4, 5, 6, they are all distinct, and we find only the last numbers, 4 and 4, are the same. In this case, if we check backwards, in reverse traversal starting from 4, then we find this, and we know that we must remove all elements before that because it is impossible to return our array if there is 2 4s. And also, the most important, we can use set to know exactly what elements were seen and what not seen. So to better understand, we can create a story about cleaning the warehouse. So imagine you have a long warehouse aisle package with boxes, nums, and each box has a number label, but oh no, some boxes have the same numbers, like here. And you know that each box should be unique, so you wouldn't be confused. So our job is to clean up so that the boxes remain at the far end of the aisle all have unique numbers. So the rule, you have a specific cleaning robot, it can only do one thing, remove exactly 3 boxes from the front of the aisle. If there are fewer than 3 boxes left, it removes whenever is remaining. So the goal, we want to use the robot the minimum number of times, so to save as much possible, to make sure the boxes left at the end of the aisle are all unique. So how we will do it? You will start from the back. Instead of guessing how many times to run the robot from the front, let's be clever and walk from the back of the aisle toward the front. This way we figure out the longest possible section at the end that already has unique boxes. Then we will keep a checklist, our HashSet. As we walk backward, checklist will ensure that when you look at a box, it's already mentioned in checklist or not. And using that, we will check for duplicates to know exactly. So if it's not, then it's great, this box is unique. In the section, you can add it to a checklist. If yes, we found duplicate, then we need to use robot to remove elements until this duplicate will be removed. So we will calculate the robot's runs. So when we find the first duplicate from the back at position for I, we need to remove all boxes from first, starting basically an array from 0 up to I. So how many times do you run the 3 box robot, remove 3 boxes this time? It's count by using I divided by 3 and added 1, so we start with new element. Size the first duplicate found from back. This is the minimum number of runs needed. And we found our answer. And if everything is clear and fine, we just return 0. So let's describe algorithm. In our case, algorithm we will use Traversal and HashSet. And we will use HashSet to storing. Time complexity will be big O of n. That's when you traverse array once, and space complexity in worst case scenario will also be big O of n, as we need to store all elements in our set. However, it will be less because we have constraint of store elements. So no more than store elements, so we can kind of think about that as of 1. So we will make scene equal to set. So we have our set, and then we start for I in range len nums, and we use backwards. So we -1, -1, -1. Store from backwards to forward. Then we check if nums I will represent the last number in the array. So for example, here or here, the last number in scene. So if it in scene, so we found our duplicate like here, then we need to return I divided by 3, and that's step 1. Otherwise, else, if for example I was here and we go to 5 and it's fine, then we just use scene add nums I. We just added this element to our so far scene HashSet, because HashSet has unique ability to store only unique values. And let's run our code. Oh, I forgot that in. Slightly typo. Great. And let's submit. And it's pretty efficient. In memory, it's very efficient. So thank you for your attention. If you have any comments, ideas, feel free to write them. Have a nice day. Bye.